Okay, so we're going to chat this morning about about RPCs, or remote procedure calls, which are when an application wants to make a call to a component and the component is sort of remote, maybe it's got a network or something like that. In like a microservices world, this might be making a HTTP call or something like that to handle a microservice. That's a pretty common pattern. So I'm going to talk a little bit about how Codat have sort of approached this problem, how that relates to maybe how other people approach that problem, and some of the things we've learned along the way, and some of the useful bits that are new in .NET specifically for being able to do this. But the principles are all kind of universally applicable. So here, there aren't too many GIFs, because if people are on a WebEx, obviously GIFs, and if I move around a lot, that's going to be quite annoying for people's bandwidth. So there aren't a lot of GIFs in this, I apologise, but there are a few. So here we've got Mo, who's receiving a call from some remote system. He's turning around into the domain to get an answer. So what do we need from our RPC library or framework, or however we're going to do this? So we've got a few necessary features. Number one, and always number one, is how do we handle end-to-end error handling. I always think it's good to think about how the system will fail, and then think about how you're going to make it work, because invariably it will fail. We want things to be type safe. This is obviously a sort of .NET-y lent thing, but generally some form of type safety, some sort of consideration of contract or something like that, and no matter what language you're using is quite useful. Easy setup for sort of defaults, right? You want it to be kind of as plug and play as possible, half of least resistance, all of least power, and all that kind of stuff. And for authorization, you don't want to have to bother with faffing with authorization every time. Well, you want to make sure that your inter-service remote calls are authorized sensibly for all sorts of security reasons. Maybe transparent auth should be after error handling, I think that's priority. So, sort of to build out all of these features, there are kind of two parts to every RPC library or framework, right? There's the server, which is the kind of receiving component from the call, and that's got to be able to return information to some sort of strict contract that you want to operate on, and then a client, which is the sort of receiving end and also the kind of signaling end, that needs to have all the stuff built into it to be able to decode whatever you're getting back and transfer it into whatever the domain needs to know about. So these are the two things that kind of exist on the service boundary, and then inside these two things are kind of our domain for that particular microservice or whatever. So that first kind of feature that we need, that shared contract for error handling, this is kind of an example of the sort of thing that you might want to think about, I guess. So on the wire, some sort of contract that kind of defines everywhere how errors are going to be handled and communicated between parts of the system. Got some sensible things here that you might want. For instance, some sort of ID to correlate logs and correlate requests that are pinging between different services, so you can sort of trace system behavior. Some sort of error message, so either something machine readable or human readable that kind of tells you what has gone wrong and sort of why. And then a service reference, because obviously if there's an error has occurred, you kind of want to know where it originated from, even if it's being passed around, to some upstream or downstream service. You kind of want to know where it's come from. So here we've put some reference to that originating service. So in the domain, how do we express these errors to get out through the service boundary? So there's two approaches. I guess you can use some sort of strict contract for your request response type stuff happening in the service boundary. So this is a kind of a version of a bit of F# code. So we have a result which can wrap up either some sort of error or some sort of success. So we've got some strict contract. For everything that comes out, it's got to be a result. It's going to be one of these two things, either an error or a success, or and I guess this is sort of classic .NET things. If you want to get out of a domain quickly, throw an exception, and then at some point on the service boundary, this exception gets translated into whatever our contract is on the wire for our RPC. So I like this, but this is maybe more of a headache for some systems, right? Because you need to pass this result all the way through your domain code, and sometimes that's onerous, and people in C# are much more used to throwing exceptions when things goes wrong. It's quite a useful go-to, right? Either for good or bad reasons. So Codat uses the throwing the exceptions just to get out the boundary as quickly as possible. But obviously both are valid. The important thing is making sure you have this shared contract with the boundary. So once you're out of the boundary, the client and server kind of need to have some way of understanding what's on the wire and knowing that when you translate back into the domain from your remote call, you have some way of kind of making sure you're decoding that contract or encoding that contract in a sensible way. Now, in a HTTP world, which I think most people are probably doing RPC over HTTP these days, and microservices, if they're doing synchronous stuff, probably over HTTP. And we have content negotiation. So for a request, you specify what content I have, and you specify what kind of content you will accept. And then obviously a response will say exactly what kind of content you're passing out. So this is, people will be familiar, I guess, of calling an API and specifying that you'll accept application/JSON, and you'll get back a lot of JSON, or specifying text/HTML and getting a web page that looks pretty and shows you what the data is. This is quite important, obviously, because that shared contract has to be expressed in something that's going to be serialized, deserialized on the wire. And so you want to make sure that your modes of serialization and deserialization are kind of understood by both ends, and it's kind of done in a nice, opaque way. Cool, so that's our contract. We can now send it over the wire, get it out of our service boundary. That's all great. So there's some cool stuff to help you do this in .NET now. HttpClient, I think, has been knocking around for a bit. I don't know what version it appeared in, but it's been knocking around for a while. And HttpClientFactory is something that's a bit newer. I think this was to get over some of the pitfalls of using HttpClient explicitly. It's really easy to use badly. And so HttpClientFactory kind of was an abstraction over handling the lifetime of your HTTP client to kind of do it better. So let's look a little bit into DIYing that stuff that we just talked about using HttpClient. So one, our error contract, right? So how do we express it? If you're calling something in an RPC, you probably wanted users, or you wanted, I want the comments on this post in some social media app, right? You don't want an error, so you need something on the service boundary that kind of makes sure the domain understands how it's being handled. So we've got an example here of using the HTTP client. So we create a HTTP request message, which is our method to get the actual resource we want in terms of this RPC. We can send it using the client, using the send async. We're reading back the content, and then we're checking this response. And we're saying if the response is an error, then the content is probably going to be our error contract. If it's not an error, then deserialize it to whatever our expected return type is. Now you can do what you want in terms of, as we were talking before, about the sort of two different methods of handling errors and successes through your application. You might say that this error contract will now get turned into an error result, like I've got here in that F# example, or a success result that's kind of passed out of your client code. Or here, maybe you throw an exception with some sort of specific kind of exception to say something's gone wrong in a remote service call. So that's relatively easy. Also, here we've got stuff with JSON convert. I think most people in .NET are familiar with JSON.NET these days, but obviously if you were doing something, if you're using something else on the wire, or different services returned different kinds of data, you'd have to do some form of content negotiation here, which isn't done for you in HTTP Client. So yeah, pro tip, in the example, just for expediency and clarity, I've used JSON convert deserialize object. If you're doing RPC, you've already got network latency involved. There's no point in adding a whole bunch of serializer latency as well. There's lots of really good stuff in JSON.NET to do stuff with streams, and therefore not having just allocated strings all over the place for every HTTP request you make. So I'd suggest it's not that much more code, right? It's like one more line of code to do it with streams rather than with strings, and you'll save yourself a lot of kind of headache with sort of memory and unnecessary CPU usage for those remote procedure calls. So obviously HTTP client supports this by reading the body content directly as a stream rather than pulling it out as a string, which is really useful. You guys, anyone else here used REST Sharp before? Good. It's awful. Right, so yeah, type safety. How do we have our client code that's calling out to these services? How do we make it type safe with HTTP client, HTTP client factory? Well, we can declare sort of these nice typed interfaces and nice classes that kind of wrap up the functionality for being able to call these remote services. So here we've got my service, it's got some specific client that takes a HTTP client, which has the lifetime is all kind of managed for you, and we've got our contract is defined here in a type safe way. So as before, we were kind of doing all of this explicitly. Maybe in your code you can kind of wrap it up nicely inside behind some client interface, which is super cool. How do we sort of set defaults and do all that auth kind of stuff that we were talking about before that we know we want? Well, in HTTP Client Factory, which is the thing that will build our clients, it allows you to sort of specify direct bindings. This is .NET Core using sort of service collection. So you can use a typed, some sort of typed client. And when I say client here, I mean your sort of domain client rather than the HTTP client. And that means that whenever you want one of these from your DI, it'll automatically set up these kind of sensible defaults that you want on that injected HTTP client. So really important one is this base address, which is used by the underlying handler to sort of work out connection pooling and all that kind of good stuff. And then obviously you can add other interesting things like request headers that you might always add to RPC calls, like maybe the version of the app that's calling it and stuff like that, which is useful for logging. Or you might add something here that deals with your correlation ID, which is really cool. And then we talk about auth. So you can do that. You can do that manually, or you can do something with a kind of a specialized version of the client handler. So it looks kind of, I think as soon as you start seeing things like configure primary HTTP message handler and network credentials, and this looks kind of low level, but really actually this is just a specialization of a thing called a delegating handler, which is not very complicated. And inside there you can do pre-request and post-request type activities, similar to like filters, I guess, in an ASP.NET world. And in there, essentially, all you're doing with auth is kind of adding a sensible header, authorization header, and maybe you need to make some calls to do with something like maybe you're using identity server, or maybe using shared secrets, or basic auth, or something like that. And so it's quite easy to kind of wrap that up inside the client handler. It's not too scary, and then you know that whenever you make a call with that typed client, it's kind of under the hood fairly opaquely, but nothing magic. It's going to sort of handle that for you, which is super cool. So we talked about HTTP Client Factory, and all that stuff I said was kind of setting it up in terms of getting a HTTP client. How does it work with the factory? So essentially, the HttpClient Client Factory is just a service that automatically gets registered in the DI in .NET Core when you do that, use HTTP client stuff. And it's just got one method called getService that either takes a type, some generic, which is a typed one, or some name of a service. So this is quite good if you want to use named service rather than typed ones, if you're kind of building another layer abstraction on top of those clients and wrapping them up with your own flavor. Obviously in a lot of systems people kind of have the way that they're handling these things, and you might want to wrap it all up in a kind of in something around the HTTP client. So that's all it is. It's not a very complicated interface, but it's quite useful. Handle the lifetime of those clients for you. So if you don't want to do any of this in that kind of DIY way using HTTP client, there's a few stuff out there. So GRPC is getting quite popular, I guess. So there's native. Someone has written a library at Microsoft for GRPC support for .NET Core 3. So you'll be able to take a GRPC proto file which describes kind of like a service description along with a protobuf contract, and from that you can generate C# classes that will kind of do all of this magic for you. Obviously, if you're using something like this, it's kind of all in. With GRPC, you kind of have to use protobuf, and you're beholden to that kind of all the stuff that they're doing. GRPC, if you hand roll it, okay, there's a little bit more code to write, but hopefully we've shown the 20 lines of code that you have to write to be able to do it yourself, and maybe you've got a bit more freedom to kind of do it in the way that best suits you. So that was it. That's all I wanted to talk about. Just a quick lightning talk. Any questions?
If you move to GRPC and protobuf, how much impact is that on debugging when you can't just sort of look on developer tools and see the JSON and text?
Yeah, nightmare. So there are tools. This GRPC support comes with a Visual Studio plugin. That obviously the plugin reads your proto file and then kind of adds a debugging layer into Visual Studio to kind of help with that. But yeah, one of the pitfalls of going all in on something like this is that, like you say, on the wire and a lot of the other things, auth methods and stuff like that, kind of taken out of your control. The other thing is it's designed specifically to have kind of cross-platform, cross-language support. So your proto file is agnostic of how that's being implemented. It's just a schema, like SOAP or something, very similar to SOAP, I guess, in a lot of ways. And so, if you're writing something in Go, or you're writing something in Java, I guess that's where it kind of is really great. If you're the kind of shop that's writing everything in .NET, then yeah, maybe you don't need to kind of have this untype-safe thing, this proto file, which maybe is prone to error. And once again, it's just another schema, not expressed in code. So going back to kind of having a WSDL, I don't know whether people seem to have moved away from SOAP and they're re-implementing it in a slightly different way. It's not XML, so it must be better, right? But yeah, I think exactly that debugging experience is probably not going to be great. The other thing about hand rolling it and doing that content negotiation, and it's kind of how we do it at Codat, is that what content you can accept and what content you're sending, you could tweak maybe depending on what environment you're in. Maybe in production, you want all of the media types to be protobuf or message stack or something like that. It's super performant but binary serialized thing, because in production when things go wrong, maybe you want to sort of have a look in logging, but you're not really debugging necessarily in production. But maybe in your sort of testing environment, staging environment, when your integration or local environment, you kind of want to switch off protobuf for a time and use JSON so you can see what's on the wire. With GRPC, I don't think that's possible. So we hand roll it, and that's one of the reasons. David?
You talked about using streams all the way down rather than using strings.
I did.
What sort of performance improvements have you seen using that approach?
So doing this instead of this. So something like 50 to 100x on especially like things where maybe the amount of work you're doing in the domain is quite small. So the kind of proportion of time spent doing all of those other activities starts to dominate. And so maybe you're kind of calling, you're getting a fairly large object, but you're not doing very much with it, and then responding. The activity is probably very small, but that serialization is massive. And the other thing is all of the string allocation. So if you're doing lots of calls, it takes a long time for the GC to get around to being like, okay, you've allocated a huge number of strings in this large object thing, or wherever they are, and I need to clear them up. Here, you don't really have any of that allocation. This stream is coming straight out of the kind of network buffer into .NET, so it's not sitting around doing that magic. So yeah, quite considerable performance differences. For both memory and for CPU.
How often do you put an A when you keep typing JSON?
It's the other way around. When I type my name, I always forget the A. I think I probably type this far more than I type my name. Got it? Oh, is there any? There might be some online, maybe. Is there any questions from the guys on the WebEx? Type them in and I'll see if I can read them.
Nobody's typing yet. Give it 20 seconds or so. I'm going to go with no.
Okay. Thanks, guys.
Cool, thank you. Cheers.